Hello everyone, let's proceed to the next question. Here we are given a particle is moving along the xy plane, that is, it is a question of 2D motion. Its initial velocity is 4 I cap plus 8 j cap meter per second and its acceleration is 2 I cap minus 4 j cap meter per second square. We have to find the time when the particle will cross the x-axis. That means we have to find the time when its y coordinate becomes 0. This question indirectly asks the time when its y final becomes 0. And then we have to find the x coordinate of the particle at this instant, and then we have to find the velocity of the particle at this instant. Here we are given initial coordinates 4, 10, obviously in meters. Let's first plot a rough diagram. Suppose this is the xy plane. Here we are given initial coordinates is 4, 10. Suppose this is the point 4, 10. And we are given its initial velocity is 4 along x-axis and 8 along y-axis. That means is in this direction it is 4 meter per second and along y-axis it is 8 meter per second. And also we are given the acceleration is 2 along x-axis and minus 4 along y-axis. That means in this direction it is 2 meter per second square and it will be along negative y-axis, and this is 4 meter per second square. Then we have to find the time when the particle will cross the x-axis. That is, we have to find the time when its y final, the final y coordinate becomes 0. For that we can use the equation displacement s is equal to ut plus half a t square, because this is the case of uniform acceleration. As we can see that the value of acceleration is constant. So for the first part we can write, let at time t is equal to t, its final y coordinate becomes 0. So we can write delta y is equal to ui t plus half of ay t square. This delta y is simply y final minus y initial. Y final is, suppose y at time t, or we can write y final minus y initial is equal to uy times t plus half of ay times t square. I am applying this equation in along y-axis. So we have y final position of the particle along y direction is 0. So we can write here 0 minus y initial is given as 10. So we can write 0 minus 10 is equal to uy. Here we can see uy is the velocity of the particle along y direction at time t is equal to 0, and it is 8 meter per second. Suppose this direction is positive, so this direction will be negative. So 8 times t plus half of, here ay is along minus y in direction, so it will be minus 4 times t square. If we solve this equation we will get 2 times 2. So if we bring this term along left hand side we will get 2 times t square, and this is minus 8t minus 10 is equal to 0, or we will get t square minus 4t minus 5 is equal to 0, or we simply get t minus 5 t plus 1 is equal to 0. Minus 5 ones are minus 5, minus 5 plus 1, that is minus 4. So t, from here we can say either t is equal to minus 1, which is never possible. So t is going to be 5 seconds. So this is the answer of the first question. That means at the instant t is equal to 5 seconds, the particle will cross the x-axis. That means its y coordinate will become 0. Now in this part we have find t is equal to 5 seconds. Now let's proceed to the next part. Part number 2. Here we have to find the x coordinate of the particle at this instant. That means at t is equal to 5 seconds we have to find the x coordinate. So we can write x final minus x initial is equal to delta x is equal to ux times t plus half of ax times t square. Here I am applying this equation as is equal to ut plus half a t square along x-axis. So we have to find x coordinate at time t is equal to 5 seconds. So x at time t is equal to 5 seconds minus x at time at initial time, that means at initial time we know it is 4, so we can write here 4 is equal to uxt. Here we can say initial velocity of the particle along x direction is 4, so 4 times t, and we know t is 5 seconds, so we can write 5 plus half of ax. Ax is 2 meter per second along the positive x-axis, so we can write 2 times 5 square. So here we are getting x at time t is equal to 5 seconds is equal to, if we bring this 4 into the right hand side, we will get 4 plus 5 into 4 20 plus 5 squared, that is 25. So this is 24 plus 25, that is 49 meters. So therefore the final x coordinate at time t is equal to 5 seconds is 49 meter. So we can write the coordinates of the particle at t is equal to 5 seconds is x is 49 and y is 0. These are the coordinates of the particle at time t is equal to 5 seconds. Now let's find the velocity of the particle at this instant, that is at t is equal to 5 seconds. At t is equal to 5 seconds, we have to find the velocity of the particle. That means we have to find two velocities along the x direction and along the y direction. Then we can write vectorially. So let's find first vx. We know vx is equal to ux plus ax times t. So we have initial velocity of the particle along x direction is 4 plus ax is 2 times t is 5. So 5 to 10 plus 4, 14 meter per second. Similarly, Vy is equal to Uy plus Ay times t. So here we have Uy is 8, Ay is minus 4 times t is 5. So we have 5 for 20 minus 20 plus 8, that is minus 12 meter per second. So therefore we can write velocity of the particle at time t is equal to 5 seconds is Vx I cap, that is 14 I cap plus Vy j cap, that is minus 12 j cap meter per second. So this is the answer of the third part of the question asked. Thank you.